Chapter 8, Electromagnetic Waves. Now see, we already studied Ampere circuital law, Gauss's law for electricity, Gauss's law for magnetism, right? All these things we studied. So, scientist James Clerk Maxwell used these laws and prepared some differential equations. And when he prepared these differential equations, then he felt something is missing in this one. But there is some controversy in the calculation of field. So then he introduced that particular term as displacement current. What is this displacement current? We will discuss this thing. But after that, when he solved the differential equations, then he studied this thing only with the help of calculations. There is the existence of electromagnetic waves in nature. And he suggests this thing, not only the electric current produces the magnetic field, but varying electric field also produces the magnetic field. Okay. And when he calculated the velocity of these electromagnetic waves, then it came exactly 3 into 10 raised to 8 meter per second, which is the velocity of light. So he also suggested this thing, light itself is electromagnetic wave. But experimental evidences were not there in those days. Okay. Now, let's first understand the displacement current. What is the displacement current? That first of all we have to understand. Okay. Suppose here we take a capacitor, which one is connected with the battery. Now, suppose we consider here different surfaces, but having same boundary, and then we calculate the magnetic field at point P as shown in the figure. Suppose first we consider the surface, which one is with radius equal to R and perpendicular to the current. Okay, this current is flowing through the wire, which one is connected with the battery. So here the loop shown in the figure that we can consider as Amperian loop, because that is enclosing your considered surface. Now if we use Ampere circuital law, then integration B dot dl, that is mu 0 I. Now B integration dl, that is 2 pi r, that is equal to mu 0 I. In short, we can say this thing. Here we will get value of B. But now see, suppose we consider another type of surface for which the boundary that remains this same loop. So here if we consider the pot type surface like this, the bottom of it that is passing between two plates of the capacitor. Now, if we think about the current passing through this particular surface, so between two plates of the capacitor there is no current. It implies that if we use Ampere circuital law, then the magnetic field at point P, that will come to 0. Here he observed the controversy, Because if at point P magnetic field is there, then if we consider any surface, and by considering any type of surface, if we take the loop enclosing that surface and if we apply the Ampere circuital law to that, then there should be the same field. Now suppose we consider the box type, cylindrical box type surface, and again here at point P, the loop enclosing the surface is same one, but the bottom of this one is between two plate of the capacitor. So again here through the bottom the current is not flowing. So B will be 0. This is the controversy. Clear? But then after what he suggested, see, between two plate of the capacitor, no doubt current is not there, but electric field is there. Now, in chapter number 2, we already studied this thing, electric field between two plate of the capacitor, that is given by E equal to Q upon epsilon 0 A. Clear? Now, flux passing through the surface between two plates, we can write that is flux equal to E into A, area of that particular surface, which one is between two plate of the capacitor. So E, that is Q upon epsilon 0 A into area of that surface, that is Q upon epsilon 0. But here this flux that is changing one. Why? Because charge on the capacitor is varying. When we switch on the circuit, the current in the circuit changes from 0 to I, and charge on the capacitor that also changes from 0 to Q. Whatever is the time interval, but it is changing one. So if charge on the capacitor is varying one, then flux will change. So we can write d phi by dt, that is equal to d by dt. Now phi, that is Q upon epsilon 0, but epsilon 0 is constant. So if charge is varying, then we can write 1 upon epsilon 0 dq by dt. Take this epsilon 0 on left hand side and make dq by dt as a subject. So dq by dt, that is epsilon 0 d phi by dt. But dq by dt, as per definition, that is the current. And this current he termed as a displacement current. That is the displacement current. Okay. Now, here in Ampere circuital law, he felt this thing, something is missing, and he added that particular missing term as displacement current. So he rewrite Ampere circuital law, integration B dot dl, that is mu 0 into, now here the current in the circuit, that is of two types. Battery to the plate of capacitor, that is the conduction current. Simply the current is flowing, as we discussed in the previous chapter, due to flow of charges, and that is the conduction current. But between two plate of the capacitor, there is the displacement current. So when the conduction current is there in the wire, at that time displacement current is not there. And between two plate of the capacitor, where there is the displacement current, there is no conduction current. Okay. So net current he represented by conduction current plus displacement current. So one can write mu 0 into IC plus mu 0 into ID. So integration B dot dl, that is mu 0 IC plus mu 0 epsilon 0 d phi by dt. And this particular equation prepared, that is called Ampere-Maxwell's law. So Maxwell's equations are given to you in the text in that blue box, and these four equations means set of these four equations, that is called Maxwell's equation. And with the help of these particular calculations, mathematically he proved this thing, there is the existence of electromagnetic waves in nature, and light itself is electromagnetic wave. So in this way he suggested the existence of electromagnetic sources of electromagnetic waves. So when Maxwell suggested this thing, there is the existence of electromagnetic waves in the nature, but that electromagnetic wave theory suggested by Maxwell was not accepted initially because experimental evidences were not there. Okay. Then after scientist Hertz produced electromagnetic waves in laboratory, right? So how he produced electromagnetic waves in laboratory? So with the help of oscillating charge, he produced the oscillating electric field in the space, and oscillating electric field produces the magnetic field, and this oscillating electric and magnetic field are self-sustained, and they produces each other, right? And the oscillations of electric and magnetic field are mutually perpendicular to each other. It implies that here we can say this thing, the kinetic energy associated with the oscillating charge is converted into electromagnetic energy, because after all, electromagnetic wave, that is the form of energy. That is the form of energy. So electromagnetic waves are self-sustained. So oscillating electric field produces the magnetic field, and oscillating magnetic field produces the electric field, and the process will continue. Okay. So after Hertz, scientist Jagdish Chandra Bose produced electromagnetic waves in laboratory up to the wavelength of 5 millimeter. Okay. So 5 millimeter to 25 millimeter wavelength, he produced electromagnetic waves in laboratory. Okay. So we can say this thing. Then after this electromagnetic wave theory was accepted worldwide, because experimental evidences for the presence of electromagnetic waves in nature obtained. Then after scientist Marconi produced electromagnetic waves in laboratory, and he was succeeded in the transmission of it. He transmitted electromagnetic waves from one place and received those electromagnetic waves at another place. And we can say this thing, this particular work, that is the foundation of the modern communication. That is the foundation of modern communication. Clear? So then after, so many scientists worked in that particular direction, and scientists came to know about the entire electromagnetic spectrum. Electromagnetic spectrum, that is nothing but the collection of electromagnetic waves with wavelength starting from 10 raised to minus 14 meter to 10 raised to 7 meter. Clear? And this entire electromagnetic spectrum is continuous in this particular range. There is no demarcation line in this particular electromagnetic spectrum. It implies that the electromagnetic wave with each and every wavelength between 10 raised to minus 14 meter to 10 raised to 7 meter is there in the nature. And depending on the characteristics of the waves with different wavelengths or frequencies, this electromagnetic spectrum is divided in different parts. So later on we will discuss this entire electromagnetic spectrum. Now the existence of electromagnetic waves established. So then after we have to discuss the characteristics of electromagnetic waves.